According to the National Electrical Code, specifically NEC Table 310.16, it's imperative to select a breaker that is rated at or below the calculated maximum ampacity of the conductors. The maximum ampacity is the highest amount of current a conductor can carry continuously without exceeding its temperature rating. To determine the appropriate breaker size, several factors must be considered, including the conductor material, size, insulation type, ambient temperature, and the number of current-carrying conductors in a raceway or cable. When multiple conductors are installed in close proximity, such as in a conduit, their ampacity must be derated to prevent overheating. Derating involves reducing the allowable ampacity of each conductor based on the number of conductors present. This reduction is necessary because the heat generated by each conductor can affect the temperature of the other conductors, potentially leading to insulation damage or even a fire hazard. The NEC provides specific derating factors that must be applied in such situations. For example, if you have two sets of 4/0 aluminum conductors in a single conduit, you've calculated the maximum ampacity after derating to be 328 amps. This calculation involves determining the initial ampacity of the 4/0 aluminum conductors based on their insulation type and temperature rating, and then applying the appropriate derating factor for the number of conductors in the conduit. Once the maximum ampacity after derating has been determined, the next step is to select a breaker that is rated at or below this value. It's important to note that breakers are available in standard sizes, and it's not always possible to find a breaker that matches the calculated ampacity exactly. In such cases, the NEC requires that you use the next lowest standard breaker size. In your specific scenario, with a calculated maximum ampacity of 328 amps, you might be tempted to use a 350 amp breaker. However, this would violate the NEC requirement that the breaker be rated at or below the calculated ampacity. The closest standard breaker rating below 328 amps is 325 amps. Therefore, you should use a 325 amp breaker, not a 350 amp breaker. Using a breaker that is too large can have serious consequences. If the current exceeds the conductor's ampacity but is below the breaker's rating, the breaker will not trip, and the conductors will overheat. This can lead to insulation damage, conductor degradation, and an increased risk of fire. Additionally, it's crucial to ensure that all electrical equipment and components are properly rated for the voltage and current they will be subjected to. Using undersized or improperly rated equipment can also create a fire hazard or other safety risks. In summary, selecting the correct breaker size for our aluminum conductors requires careful consideration of several factors, including the conductor material, size, insulation type, ambient temperature, the number of current-carrying conductors, and the applicable NEC requirements. By following these guidelines, you can ensure that your electrical system is safe, reliable, and compliant with all applicable codes and standards. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical installations or repairs. The NEC serves as the cornerstone for electrical safety, providing detailed guidelines for safe and effective electrical installations. Understanding and adhering to these regulations is paramount to prevent electrical hazards such as overloads, short circuits, and ground faults. The proper selection of circuit breakers is a critical aspect of electrical safety. A circuit breaker is designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Circuit breakers are typically rated in amps, which indicates the maximum current they can carry without tripping. When selecting a circuit breaker, it's essential to consider the ampacity of the conductors it is intended to protect. The ampacity of a conductor is the maximum current it can carry continuously under specific conditions of use without exceeding its temperature rating. The NEC provides tables such as Table 310.16 that list the ampacities of various conductors based on their size, insulation type, and ambient temperature. Aluminum conductors are commonly used in electrical systems, particularly for larger feeders and branch circuits. Aluminum is a cost-effective alternative to copper, but it has a lower ampacity than copper for the same size conductor. This means that an aluminum conductor must be larger than a copper conductor to carry the same amount of current. When using aluminum conductors, it's crucial to ensure that the terminations are properly rated and installed. Aluminum expands and contracts more than copper with changes in temperature, which can lead to loose connections and overheating. Special connectors and terminals are available that are designed to accommodate the thermal expansion and contraction of aluminum conductors. In addition to conductor ampacity, other factors that must be considered when selecting a circuit breaker include the interrupting rating and the voltage rating. The interrupting rating is the maximum fault current that the breaker can safely interrupt. The voltage rating must be equal to or greater than the voltage of the circuit it is protecting. When multiple conductors are installed in a single conduit or cable, their ampacity must be derated. This is because the heat generated by each conductor can raise the temperature of the other conductors, potentially leading to overheating and insulation damage. The NEC provides tables that specify the derating factors that must be applied based on the number of current-carrying conductors in the raceway or cable. The derating factors reduce the allowable ampacity of each conductor, which in turn affects the size of the circuit breaker that can be used. The calculation of the maximum allowable current after derating is crucial for selecting the correct breaker size. For example, if you have two sets of 4/0 aluminum conductors in a single conduit, you must first determine the ampacity of the 4/0 aluminum conductors based on their insulation type and temperature rating. Then, you must apply the appropriate derating factor for the number of conductors in the conduit. The resulting value is the maximum allowable current that the conductors can carry. The circuit breaker must be rated at or below this value. Standard breaker sizes are available in increments of 15, 20, 25, 30, 35, 40, 45, 50, 60, 70, 80, 90, 100, 110, 125, 150, 175, 200, 225, 250, 300, 350, 400, 450, 500, 600, 700, 800, 1000, 1200, 1600, 2000, 2500, 3000, 4000, 5000, and 6000 amps. If the calculated maximum allowable current falls between two standard breaker sizes, the next lower standard breaker size must be used. In your specific scenario, with a calculated maximum ampacity of 328 amps after derating, the closest standard breaker rating below 328 amps is 325 amps. Therefore, a 325 amp breaker should be used, not a 350 amp breaker. Using a breaker that is too large can have serious consequences. If the current exceeds the conductor's ampacity but is below the breaker's rating, the breaker will not trip, and the conductors will overheat. This can lead to insulation damage, conductor degradation, and an increased risk of fire. It's also important to ensure that the circuit breaker is properly installed and maintained. Circuit breakers should be tested periodically to ensure that they are functioning correctly. If a breaker fails to trip when it should be replaced immediately. In addition to circuit breakers, other overcurrent protection devices, such as fuses, can be used to protect electrical circuits. Fuses operate on a similar principle to circuit breakers, but they are typically used in applications where a faster response time is required. The selection of the appropriate overcurrent protection device depends on the specific application and the characteristics of the electrical circuit. The electrical installations must adhere to local building codes and regulations. These codes and regulations are based on the NEC and provide specific requirements for electrical work in your area. It's essential to consult with a qualified electrician to ensure that your electrical installation complies with all applicable codes and regulations. Proper electrical safety practices are crucial for protecting yourself and others from electrical hazards. Always disconnect power before working on electrical circuits. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. And never work on electrical circuits when you are wet or tired. Selecting the correct breaker size for aluminum conductors is a critical aspect of electrical safety. By understanding the NEC requirements, calculating the maximum allowable current, and choosing the appropriate breaker size, you can ensure that your electrical system is safe, reliable, and compliant with all applicable codes and standards. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical installations or repairs. In conclusion, the selection of the correct breaker size for aluminum conductors is not merely a matter of convenience but a critical safety measure. Understanding and adhering to the NEC guidelines, particularly Table 310.16, is paramount. These guidelines dictate that the breaker's rating must be at or below the calculated maximum ampacity of the conductors, a principle designed to prevent overheating and potential fire hazards. The process involves a series of careful considerations, including the conductor material, its size, insulation type, the ambient temperature, and the number of current-carrying conductors within a conduit. Derating, the reduction of ampacity due to multiple conductors in close proximity, is a crucial step to prevent heat buildup. Once the maximum ampacity after derating is determined, the selection of the breaker involves choosing the next lowest standard size to ensure optimal protection. Using a breaker that exceeds the calculated ampacity, such as opting for a 350 amp breaker when the maximum ampacity is 328 amps, can have severe consequences. Such a mismatch can lead to undetected overcurrents, causing insulation damage, conductor degradation, and an increased risk of fire. Furthermore, it is essential to use components rated appropriately for the voltage and current demands to avoid additional hazards. Proper installation and regular maintenance of circuit breakers are equally vital. Periodic testing ensures that breakers function correctly and are replaced immediately if any malfunctions are detected. Supplementing circuit breakers with other overcurrent protection devices like fuses can further enhance safety, especially in scenarios requiring faster response times. Compliance with local building codes and regulations, often based on the NEC, is not optional but a mandatory aspect of electrical work. Consulting with qualified electricians is highly recommended to ensure adherence to all applicable codes and standards, ensuring a safe and compliant electrical system. Beyond adhering to technical specifications, practicing general electrical safety is equally important. Always disconnect power before commencing any electrical work, use insulated tools and equipment, wear personal protective gear, and avoid working in wet or fatigued conditions. By integrating these practices, you contribute significantly to preventing electrical hazards and ensuring safety for yourself and others. Selecting the right breaker size is a fundamental component of ensuring a safe, reliable, and compliant electrical system. It requires diligence, precision, and a deep understanding of the NEC guidelines to mitigate potential risks and protect lives and property from electrical hazards.